Today we're talking about unique identifiers like UUIDs or GUIDs, how they're useful, because they are useful, and we're also going to look at how you generate them in your C programs. So welcome back, everybody. Our topic for today is one that I explored in a recent live stream. Some of you were there, most of you were not, but the topic is unique identifiers. Basically, you're building a system and you want to have some unique way to identify different objects. And these could be database entries, or they could be devices or system preferences, or really anything. The point is that you want to have some kind of identifier and you want it to be unique so that you can keep track of each of them. Now, before I get too far into it, I want to give a big thanks to all of you who support this channel. I couldn't do what I do without your help. Also, this video will have source code, and as usual, you can get access through Patreon to the source code from all my videos, as well as access to my monthly office hour, which I hold on Discord. So anyway, thank you for all of you who help out and all of you who support this channel. Now back to unique identifiers. Now, to us programmers, the term identifier just means something that we use, a name, or something that we use to identify some object or a chunk of data. So in our programs, we use identifiers. Basically, we give a name for an object, for an integer or a class or any of these things. They'll have a name and we call that name an identifier. And I don't want to confuse things because that's not really the kind of identifier that I'm talking about in this video. Instead, today, I'm talking about identifiers that look like this. Now, if you've used computers for very long, you have probably come across something that looks like this, with the standard pattern of 8 characters, then followed by 4, and then 4, and then 4, and then 12 characters, and there's hyphens in between. They're used all over the place. For example, let's say that I run a system report on my Mac and I get this long list of hardware options here. If I go through this list, I'm going to find dozens of these identifiers. Specifically, just one of them I want to show you here. If I look at storage, this is showing the different storage volumes that I have mounted. If I look at each of these, you can see there's one of these identifiers right here. And same thing, if I look at my hard drive, you're going to see, again, there's a volume UUID, and this one has a different one. And of course, as I mentioned, these are referred to as UUIDs, or the volume UUID. That stands for Universally-Unique Identifier. And sometimes, usually on Windows, these can be called GUIDs or GUIDs. That is Globally Unique Identifier. And there are some historical differences, but today they're basically the same thing. Though I have to admit that GUID is easier to pronounce than UUID. GUID is nice from a pronunciation standpoint. But whatever we call them, they're numbers that you can generate that are almost guaranteed to be unique everywhere, forever, or at least for an acceptably long time. And of course, at this point, some of you are saying, but that doesn't look like a number. I know, but it's a hexadecimal number. You can see my video on hex if you're not familiar with hexadecimal or base 16 numbers, because trust me, they're going to show up a lot in your journey as a programmer. But it's a 16-byte number, so that's 128 bits, which means that you're going to have 2 to the 128 different values. And so that's a really big number. And it does have some structure, basically some hyphens stuck in key places, and some of the bits are reserved for special purposes. We'll talk a little more about that. But for example, this nibble right here, these 4 bits right here, basically tell us what version of UUID we're looking at. So this is a version 4 UUID. And there are also some special bits over here as well, but we probably won't get into those too much today. But I do want to talk about versions really quick because there are a few different types of UUID, and I think it's useful to understand the differences. So there's 5 different types, I believe. They generally fall into 3 different categories. So the first is time and MAC address based UUIDs. That's going to be versions 1 and 2. We also have name-based IDs. That's going to be versions 3 and 5. And we have random IDs, so version 4. And the right one for you to use for your system really depends on what you're trying to accomplish. So let's look at them a little more closely. So our original example is random. Its claim to uniqueness is that there are just so many possible values that if the bits are really random, then the chances of a collision, meaning the chance that you generate 2 identical UUIDs, is incredibly low. How low? Well, if I want to have a 50% chance of a random collision, I would have to generate more than 2.7 quintillion UUIDs, and that's another really big number. But it's not 100% guaranteed to be unique, so just keep that in mind. Now, what if we're looking at the time and MAC address-based IDs, version 1 in this case? They're based on the current time and my machine's MAC address. That is its hardware address that it uses on the network to identify itself. The idea here is that over time, assuming my MAC address is unique, I should be able to generate IDs that are going to be different from those generated on this machine and on other machines, at least until sometime in the far distant future. Now, the cool thing about these IDs is that you can actually tell from looking at them when and where they came from, and which, depending on what you're doing, could be a good thing or it could be a really bad thing. It just really depends on the system. Now, the third type, the name-based UUIDs, the point of these is to map a name, a URL, or some other text to a UUID so that all of our IDs are the same size. That makes them easier to compare. And based on how they're implemented, I'm guessing that another goal was to make it so it's not obvious from the UUID what the UUID actually refers to. So we do that by using a cryptographic hash. Version 3 uses MD5 and version 5 uses SHA-1. There's already a lot going on in this video, so I'm going to save a discussion about cryptographic hashes, what they are and how they're used for later. Please do let me know down in the comments if you'd like to hear more about crypto and hashes in a future video. But I think that's enough discussion about UUIDs, what they are. So let's actually look at how we generate them in our programs. Okay, so let's start with a very simple blank program that essentially, well, right now it does nothing. I'm gonna do this in C because why not? Though nearly every language out there that people actually use is going to have some support for UUIDs because they're ubiquitous. I'm also going to use a simple makefile here. Check out my other make videos if this is confusing at all. The only difference here you're gonna see is right here, you'll see that I'm linking my program with libuuid, because that is a library that I'm going to use. It has a lot of convenience functions that make it easier to work with UUIDs. And actually, maybe I'm getting ahead of myself, but first, let's just take a look at the command line and see how we can actually generate UUIDs, okay? Because there's a simple utility called UUIDgen. And if I run it, you'll notice that I'm going to, by default, I get this random version 4 UUID right here. And if I run it again, you'll see I get another one, but these are basically just generating random numbers. And I can also add a -t here to say I want a time-based one. This is going to give me a version 1 UUID. And you notice as I do this, I'm getting far less change over time because it's based on the time and the time is moving forward. So, you do see some change, but these IDs are pretty similar to each other because they're very close in time. Okay, so that's cool. Now let's take a look at how this works actually in a program. So the first thing we're going to do here in main is I just need to actually declare a variable that we're going to use to actually store our UUIDs. In this case, there is a type called UUID_t, and I'm going to call this my UUID. Okay, so this is going to store my UUID, and then we can come down here and I can call the function UUID generate, and I'm just going to pass in my UUID. And it's going to store the newly generated UUID into my UUID. Now, some of you at this point might be a bit confused here, and that's understandable. This actually made me pause when I first saw it, and I'm still not really sure that I like it, but you might be thinking, wait, C passes arguments by value, so while I don't really know what a UUID_t data type is, my mental model is that passing it into UUID generate like this is going to pass in a copy of the variable, and normally changes to copies of variables should only change the copy, right? Right. Well, normally, if we want a function to return a value through an argument, we usually pass in a pointer. So I would expect actually to see something more like this. But that's not the way that this API actually works. So anyway, what's going on here is that under the hood, a UUID_t is actually a character array or a array of bytes. And of course, in C, when you pass in an array, it doesn't copy the whole array, but rather passes in a pointer to the array into the function. So this is effectively passing in a pointer, and it works. It is understandably a bit confusing. And like I said, I'm not sure I like it, but it's the way it is. So for today's video, we're moving on. We're just going to use it. So because this UUID_t is an array of bytes, just to show you that, we're actually going to use that in order to print it out really quick, because we want to see what this UUID was that we generated. So I'm going to make a function really quick. Let's just call it print raw UUID. This is going to print out the bytes, and we'll pass in UUIDt, call it ID. And then let's print out, just so we can keep, because we're going to print it out in different ways later on, but let's say raw, and then let's make a for loop and go up to size of UUID_t. And then down here, we're just going to print f, and let's print f the hexadecimal value of a particular byte. It's going to be the ith byte in our UUID. And then down here, we will just put in a new line Okay, so what this is going to do is it's going to print out raw and then all the bytes in my UUID. And we can only do this because, like I told you, UUID_T is just an array, and we're taking advantage of that fact. Although normally, I just want to make a point that normally you wouldn't do this with an opaque type because you're not guaranteed to know what it actually looks like under the hood. But we're going to do this for today because I think it'll help explain what's going on. So now we can come down here with our function and we can just call print raw UUID with my UUID. And so now at least we have a straightforward way to try to figure out what's actually going on. Okay, so now if I come down here, we can compile it and let's run our UUID test program. And you can see that we do get a UUID. We have 16 bytes that we just printed out, and that's great. But that's kind of, well, it's not how we're used to displaying or looking at a UUID. So instead, I want to show you another way that'll actually format it the way that we're used to. So let's come back up here. We'll leave the print raw UUID in here, but let's also make a character array UUID text. Okay, this is where I'm going to store the text that I need. And we'll come back to this in a minute, but I'm going to need a size. So we're going to have to come back and figure out what that actually is. But then there's a function called UUID unparse, which seems like kind of a weird name, but basically what it's going to do is it's going to take the UUID_T, so this my UUID, and it's going to convert it to a string. So like our UUID text that we just declared up above. So we got this, and then down here we can just say printf UUID, and we'll put %s and pass in our UUID text variable. Okay, so now this is going to be straightforward, except we need to figure out how much space do we actually need. So let's come up here and we will just pound define this UUID, what did I call it? Text size. And we know that each of our bytes is going to need 2 individual characters or 2 hexets. So we're going to have size of UUIDT times 2. And then we need to add space for 4 hyphens and 1 null character. So I'm going to add an additional 5 characters. So this should be enough space for our text representation of our UUID. Okay, now if we come down here, this should all work. So let's just try to compile it again and run it, and you can see, sure enough, now we get the more conventional formatting of our UUID. We have the raw up above, and we have the more conventional, more compact format with the hyphens. And the nice thing about it is this actually took less code because we used a built-in function rather than writing our own up here, which, I mean, either way is fine, but this way is nice. Okay, so now at this point, let's notice just a few things. So the first is that this UUID generate function generated a version 4 random UUID. That seems to be the agreed upon default. Most tools seem to go there by default. But let's say that I wanted to force it to generate a time-based one, right? So there's another version of this that we can just say _time at the end here, use UUID generate time. And now if I come down here, compile it, and we can come in here and run it, and you can see, sure enough, now I get a version 1 UUID that is based on time. Again, just like before, if I keep running it, you can see that the changes between these versions are small. And of course, if we wanted, there's also a version here, UUID generate random, if we want to force it to generate a random one, even though it does that by default. Now, of course, one thing you might be wondering right here, it kind of begs the question of what if I generate these time-based IDs really, really fast? Will I ever get identical IDs? And I'm honestly not 100% sure, just off the top of my head. There is a UUID generate safe function, which I'm guessing deals with this in some way. I honestly haven't dug too deep into it, and I'm not really sure what the time resolution is. Sure, we could find out, but just to satisfy curiosity, let's just do a quick test. Let's make a second my UUID2, and let's just call this one after the other as fast as we can. Basically, in this thread, as fast as I can do it is just one after the other. And then let's come down here and print out the raw for both. Now we can come down and make it, and let's just see. We'll see if we can generate the identical UUIDs. And you notice that they're almost the same. They're so close. They just vary by a tiny bit right here. And let's see, it looks like pretty much every time they are different, but they're just barely different, okay? So at least with this very limited test, I was not able to get duplicate IDs, If any of you are able to get it to generate duplicate IDs, I'd love to hear about it. And yes, that is a challenge, or call it a homework assignment if you like, but definitely let me know down in the comments if you're able to pull it off. But for now, let's move on with our example. So now we've generated time-based UUIDs and random UUIDs. Now let's take a look at name-based UUIDs. So version 3 and version 5 UUIDs work roughly the same way. I'm going to focus on the SHA-1 IDs, so that's version 5. Now these work a little bit differently. So to see how, let's jump down here back in our terminal, and let's just clear things up. So now let's come back to our terminal, and we're going to use UUID gen again to generate a name-based ID. Okay, so the first thing we're going to do is we're going to specify the name we want. In this case, I'm just going to say Jacob, and I'm going to add a -s saying that I wanted to use SHA-1. And then the only other thing that I need is I need to specify a namespace. Okay, now this essentially is going to work just like a salt. For those of you who are familiar with crypto, for those who aren't, it allows me to make sure that my ID for Jacob doesn't match everybody else's ID for Jacob. And this namespace is simply another UUID. So for now, what I'm going to do is actually, let's dial this back really quick and let's just generate a quick one. Okay, so this one will work just fine. Now let's go back to what we were doing and add name equals Jacob-S, and our namespace is going to be this UUID. Okay, and so now we get a new UUID, and it's important to note that every time I run this command, I'm going to get the same UUID, right? The name Jacob basically maps to this UUID in this particular namespace. Note that if I ever do change the namespace by even just a tiny bit, I'm going to get a very different UUID. And so it is important that you keep the same UUID for your namespace. If you change the namespace, all bets are off. Okay, so let's see if we can reproduce this in our program really quick. So we'll come up here, and what I want to do here is to basically create a new UUID. It's going to be my namespace UUID, and we'll just use the one we've been playing with here. So we'll call UUID parse. That's the opposite of UUID unparse. And I'm going to just take this UUID that I was using, and we'll pass in a string version, the text version of that, and put in our namespace UUID. So what this is going to do is it's going to just convert the string version into the raw version that we're going to use, the UUID_T that we can use for some of our other functions. So specifically, the next thing we're going to do is come in here and call UUID generate SHA-1. And then the first thing we're going to pass in is the output. So this is going to be my UUID. And let's pass in our namespace UUID. So that's saying this is the namespace I want to use. And then the name we're going to look up, which is going to be Jacob. And the length, which let's do string length of Jacob. Okay, so now we have, this should generate our SHA-1 based version 5 UUID. So let's just make sure. We'll come down here and let's basically just do this again. This time I just want to say SHA-1 UUID, and we'll use this text, okay? So now if we take this, let's compile it, make sure I didn't do anything wrong. And if we then run our UUID test, you notice that we end up with, oh, I forgot to save my file. That actually is really handy. So let's compile it again and run it. Now you see we do in fact end up with the same UUID that we generated before using UUID gen. And that's really cool. So at least we can reproduce that behavior. But what if you're actually interested in what's going on under the hood? So let's look really quick. I want to take you a little deeper into what libuUID is actually doing here. So basically what it's doing is it's taking the namespace bytes and it is concatenating the name Jacob in this case onto those bytes and then running this block of bytes through SHA-1, through the SHA-1 hash function. So just to verify this, just so you don't have to take my word for it, let's just put this in. Let's use echo en. We don't want a new line. And then what I'm going to do here is we're going to take this namespace ID right here. Now we don't want it in text format. So what we're actually going to do here is we're going to escape all these. So it'll put the actual hex values in binary. Make sure I get this right. And let's remove the hyphens. We just want the binary 16 bytes. Okay, so now this is going to give me the namespace in binary form, and then I'm going to concatenate my name, Jacob, right after it. And then just for simplicity, let's pipe this into test.txt. Okay, so it doesn't matter what file name I use. If we look over here, you can see, yes, I've got a bunch of weird characters before Jacob. That's okay. Just wanted you to see that it generates, basically it's got a bunch of binary junk in front of my name. So that's just fine. But now what happens if we take this and we say SHA-1 sum test.txt, okay? Now what you're gonna see is this looks a whole lot like the UUID that we generated right here, right? Now how close? Let's take a quick look. Let's just come up here and make a new text file. And this is the UUID, and this is the SHA-1 hash that we got of our text file. And now if we come in here, let's just see these things line up pretty well. Let me just add hyphens in all the right places. And okay, so you can kind of see what they're doing here. Basically what they're doing is they're taking the SHA-1 hash that we got and they're adding the hyphens, of course, breaking it up. And you notice there are a few places that change. So right here, you can see, we'll just make it a little bit bigger here, make it a little easier to read. But basically here, what you've got is you're replacing this F with the version information, and there's some more variant information that's being replaced here, okay? So otherwise, it's just our hash with some version information replaced. And you notice that it also drops off a bunch because our SHA-1 hash actually has more bytes in it than we can fit in our UUID. So this is pretty straightforward. One thing I want to note about the security of these named IDs. So both MD5 and SHA-1 have been shown to have some vulnerabilities, and we're throwing away some of the bits in the hash. So if you absolutely need security here, meaning that if you really need people to not be able to generate collisions or figure out what names generated what IDs, you might really want to use a more secure hash function and generate some maybe non-standard UUIDs, or just roll your own identifiers, maybe just storing straight hashes. So the right answer is going to depend on your specific application, your specific system, and its needs, but I hope this is interesting. I hope it's helpful. I hope you learned something new today, and if you did, please like the video, just to tell the YouTube algorithm that you like seeing this kind of thing. Subscribe so you don't miss next week's video, and until then, happy coding, my friends. I'll see you next week.